Number one, a particle started at the origin and moves along the x-axis with its velocity given for t greater than or equal to 0. Where's the particle when t equals 4? There's a couple ways to approach this, and later on we're going to see that connection. You might see it today a little bit, but based on what we're doing right now. This was intended to be an integral problem. You might have done it differently. What function did I give you? I gave you velocity. And if I'm taking the integral, remember, what does integral mean? The area that's bounded by the curve and the x-axis, right? What am I finding when I'm finding the area under the curve? If velocity is the function, what am I finding? What? The distance the particle travels, right? And just to go back real fast, if I said the velocity is 5, if velocity is 5, constant value, and I want to know how far the particle traveled after 3 seconds or after 3 whatevers, then we would say distance equals rate times time, right? So distance equals the rate, which is 5, and the time, which is 3. So really, the distance that the particle travels is related to what in the graph? The area under the curve, which we call the integral. So it's the same concept. It's just the rate is not a constant. So, number 1, the function is t squared from 0 to what? 4? Okay. So if this is v of t, then what would the setup be to find the distance the particle has traveled? What would the equation be? Nobody knows? Oh. Yeah, but it's not a constant, so you can't say that. What? What do you have to take? What'd you say? Dx. Not x squared. T squared dt, right? Now this is the distance traveled. What else do we have to include to find position? Its original position, right? Which is 0. So I'm going to say 0 plus. It could start off somewhere else, and we'll get to that in the future. But this is just now a calculated problem for your case right now. So what did you get? 21.333. Repeating. So 21.333. There is a different way of approaching this, and it's kind of the connection between what an integral is and differential calculus. If I give you the velocity, how do you go back to position? The antiderivative. So v of t equals t squared. How do I find, this wouldn't necessarily be position, well, it would be position, okay. So we'll say x of t equals what? 1/3 plus c. In order to solve this, we need to know what c is. What's the one point that we have? 0, 0, because it started out, when t equals 0, it started out at position 0. So 0, 0, we're going to plug that in. So position is 0 when time equals 0. So c is 0. And so you can maybe see that this c value is whatever that value is in front. So our position function is 1/3 t cubed plus 0. Right? And so what is our position? Our position is x of 4. So it's 1/3 of 4 cubed. 64? I don't think so. Is it? 4 times? Oh, never mind. I was thinking 4 to the 4th. 64 over 3, which is the same thing as 21.333. You guys okay with that? So we're going to see that connection as time goes on. Okay. Number 2, we want a 13-foot ladder leaning against a house. So there's the house. There's the 13-foot ladder. And I'm putting this in right now because is the length of that ladder changing? No, the length is not changing. As the ladder slides down, what's changing? that height, I guess you could say, and the base. So what's the equation here? True. Equals 13 squared, right? And then it gave us some information, but remember, we never plug things in until we take the derivative. Why was I allowed to plug the 13 in first? Because it's constant. It's not changing. If you wanted to, you could say b squared plus h squared equals c squared, and just call this c, I guess. And we'll just say c equals 13. Then take the derivative of both. I'll do both of them alongside each other. What's the derivative of b squared? 2b times b prime, because b is a function of time, right? Plus 2h times h prime equals 0, because the derivative of a constant is 0. If I deal with this over here, it would be 2b times b prime plus 2h times h prime equals 2c times c prime. Right? Let's plug in what we know. 2 times what's b at the moment that we're considering? Did it give us that? Okay, at the moment the base is 12 feet from the wall. Does it give us what b prime is? It does? Okay. So it's moving away from the wall at 5 units, 5 feet per whatever. Plus 2, does it give us what h is? No. But once we've taken the derivative, we can figure out these values. So we do the Pythagorean theorem and we get 5. And then does it give us h prime? No. How did I know what? How did I know what? It's math. And I wrote the problem. And this is what's called a Pythagorean triple. Like if you know two sides, like a 3, 4, you should know the hypotenuse. Do you know it? 3, 4. I know, but it's the next triple. There's 3, 4, 5, and the next prime triple is 5, 12, 13. Anyways, plugging in here would be the same thing, but the key to this, 2 times 13, but c prime is 0, so that whole side is 0, and you end up with the same values here. So this is going to be 120 plus 10h prime equals 0. 10h prime equals negative 120. H prime equals negative 12. Does that make sense? The h prime should be negative. Yes, because this length is doing what? Decreasing, therefore its derivative is negative. The question, though, and you've got to be careful with this, it says, how fast is the top of the ladder sliding down? 12 what? What's the units? Feet per second? Okay. The rate is negative, but the speed is always absolute value of the rate. Right? And besides, it kind of implied the negative value when it said that it's sliding down.